Imagine you're an operation manager managing thousands of pallets of perishable goods every day. Trucks are arriving, shipments are leaving, and you're constantly making decisions about where inventory should go. But here's the problem. You don't actually know the freshness status of the food inside the pallets themselves. Currently, routing decisions are made utilizing expiration dates, temperature logs, and rough estimates. And sometimes this works. But sometimes a pallet that looks good today spoils in transit, arrives rejected, and the entire shipment becomes a loss. At SpoilSafe, we are managing over $1 trillion in food waste annually as one of the reasons why spoilage occurs. And over 14% of shipments are lost between harvest and retail. What if you can see the actual freshness signals coming directly from the food itself and route every pallet to the right destination before spoilage ever occurs? This is what SpoilSafe enables.
Yes, so SpoilSafe is a predictive decision layer for freshness supply chains. We create a low-cost module that's distributed across the supply chain that takes environmental signals from food as it degrades. This goes into an analytics pipeline that uses machine learning and a bunch of other things that eventually predicts shelf life in real time. Now, why is this useful? Well, it's not because of the shelf life or the predictions, but it's because we enable actionable decisions. SpoilSafe uses these predictions along with past product trends to determine to create recommendations for what an industry should do for the most profitable inventory setup, like move a pallet from point A to B based on how ready it is to spoil. In the end, this gives us three major advantages. One is that we get freshness signals directly from the product. Two is we're low cost, deployable, and scalable. And three, and most importantly, we turn data into real-time analytics that operators can act on.
For a typical warehouse generating $40 million in annual revenue, spoilage represents roughly $5.6 million in losses each year. SpoilSafe aims to recover 15% of that loss with a deployment cost of $120,000. That's over a 5x return on investment. SpoilSafe is working with Giant Eagle as a design partner, and we are conducting over 50 interviews with people. And SpoilSafe is conducting over 50 interviews. We've raised over $100,000 from InnovationWorks, and we are active partners of the Alpha Labs and Robotics Factory community. SpoilSafe transforms invisible spoilage signals into predictive supply chain decisions. And our team is working hard to help companies recover revenue, reduce waste, and deliver fresher products. Thank you.
Yes.
So what exactly does the hardware?
Rohan will talk a little on this now.
Yeah, so basically SpoilSafe is built on a hardware and software interface. So the hardware is specifically this sort of AirTag sensor that clips onto specific pallets of foods, right? In warehouse management, you have inventory of perishable goods that are specified by either produce, other things that have expiration dates and such. So on each of these pallets, you'll have a SpoilSafe sensor that is essentially collecting gas, temperature, and humidity data that goes into our software dashboard and ML algorithm in order to determine the hour to spoil estimate, and based on that, help inventory managers make better decisions.
Yes.
So I have, is this thing on?
Mm-hmm.
Is this thing on? Yeah, okay, yeah. So I have a question about some of the numbers in here.
Yeah.
So the reason I'm curious is because the 526 million number you put above is the amount of food wastage due to including not even bothering to refrigerate at all. So that's a global figure including developing countries. And then over in the other number that you gave, which is, suppose that you said some percent is spoiled in each, there we go. Oh, the one that was right before. You said the recovering 15%. What I'm curious about is, right now people are just using refrigeration and they're using temperature sensors. So the relevant number to check is not how much money would you save comparing using SpoilSafe versus not even bothering to check temperature. What's relevant is there are already temperature sensors. So what I'm curious about is that 15%. What is that, right? Because the 526 million, you guys use a global figure including no refrigeration. So that's like a little bit of a bogus number. So this number here, what I'm curious is, if they had a choice to use the normal temperature sensors, and they did that, and then they use SpoilSafe instead, are you saying they'd recover 15% more? or is it like 1%?
Yeah, so this slide's a little misleading in that sense. We're comparing to existing use of temperature sensors and their loss, including those. So we're saving 15% more than they do with these existing temperature sensor startups, because inherently these temperature sensors are reactive, right? They react to loss after it's done. So it's still losing. This is just like the temperature sensors right now are just a logistics overhead that they use to like get things moving in and out, but they can't predict stuff in advance. We're saying with SpoilSafe, assuming 15%, which is extremely conservative as well, that's the savings that we.
I guess my question is, how does the 15% number come from? Where does that come from?
Yeah, so we during our whole customer discovery interviews, we talked to Giant Eagle, Heinz, Hershey's, all these big companies, and we asked for them, well, at least what they could disclose regarding their numbers. And this number, we picked the conservative side, is closer to actually 20. They were saying that, oh, these are our predictions based on if, in theory, we could predict in advance. If, in theory, this temperature palette that's been lost, if we could tell in advance before it goes bad, we'd save about 20% more of our produce. But we just don't have that sort of technology right now, and it's something we need.